The objectives today is, there's 4 objectives today. One, after reviewing this material, you should be able to describe the basic computer components and operation, explain the fundamentals of network communication, define common networking terms, and compare different network models. And my apologies, I'm still not past this thing that I had. Well, I'm past the contagious part of it, but I'm not past the symptoms. So I do apologize for the sniffling every now and then. Not much I can do about it. I took my medication like Mom said, but it just didn't, it's not working as well right now. All right, so overview of computer concepts. So some of this may be familiar to you already. Some of this will be review. In all likelihood, you'll see a lot of this information again throughout this program and throughout this degree. Mainly because networking is so central to everything IT does or information management does. Everybody needs to kind of understand how a network works and or its inner workings, and be able to discuss that with the technician in their terms in most cases. This course really just teaches you just the basic terminology that you'll see out in the field. So if for whatever reason you're on a project management team in the future, you can speak their language and you can hire skills based on these concepts. Networking really hasn't changed over the past 50 years. It's changed a little bit in that there are things on top of the main network components, but for the most part, it hasn't changed in the last 50 years. Starting with your what they call BNC connection or direct connection cables. So a lot of what I'm telling you can be found also on the web, or you can find YouTube videos on it. So if I'm not explaining something well enough, you can certainly look up the concept either in the book or Google it or go to YouTube. All of these concepts are pretty much universal, what I'm teaching you. The only thing is I'm going to try to explain it on an as-needed basis for further detail. If you need that, if you raise your hand, I can certainly try to answer your question at that point in time. I have many years of background in networking. My first job was in networking at the Spartanburg Herald Journal. I think they call it Go Upstate now, but it was the Spartanburg Herald Journal. I think it's still called that. I worked there for many years as a network admin, network administrator, full admin, then a database administrator, and so on. So I've got years and years experience running networks. So I may run through some of these things quickly. So if I do it too fast, just raise your hand and I will slow down. I'm just used to this stuff is just a muscle memory for me. So I will probably go through things rather quickly. But I will try to go bullet by bullet. Most devices encountered when working with a network involve a computer. Yes, and everything on a network involves a computer, because a tiny computer is in just about everything now. So you can pretty much say that if a network's involved, it's attaching to other computers. They may not be Windows computers. Most obvious devices and workstations and network servers running operating systems aren't running operating systems such as Windows, Linux, Unix, and Mac OS. You have other devices out there. It's not just these desktop operating systems, they're mobile operating systems as well. They may get into that a little bit later. They have left it off of this list for some reason, which means I'm probably getting ahead of myself. This also includes routers and switches, They run on networks because they have to. They're part of a living, breathing network. Specialized computers used to move data from a computer to computer and add and a network to network. Okay, that's what these are. Routers and switches move your data. And you'll learn more about them later in later chapters. Yep. And then you have non-traditional non-traditional computers include, okay, there they go. There, I was moving ahead of myself earlier. Smartphones, smartwatches, home assistants like your Amazon Echoes and your Google Homes and those things, smart things, refrigerators, even my what is that? Air fryer can connect to Wi-Fi so we can download heat settings from recipes. It's just nuts. Everything's got a little bitty computer in it, and they're networked in some way through, in most cases, you will all be on some type of Wi-Fi or some type of mobile technology like LTE or 5G or something along those lines. Any questions about this? Moving forward. Basic functions of a computer. A computer's function can be broken down into three basic tasks: input, processing, and output. I'm not going to go into that in too much detail other than when a network's involved, a network is going to need to handle all of those types of operations, so those tasks. A network's going to need to handle input, a network's going to need to process something, and the network's going to need to output something as well. So it's going to take everything that the computer does, it's going to send it somewhere. It's also going to send, the computer could send operational code over the network, and it can also, the network, of course, will spit out whatever one computer sends on one end out the other end. Think of a network as just a big, like a water hose. One end, you turn on the water, and on the other end, water comes out. And you're sending water through the hose. So a water hose is a medium, and a network cable is a medium, and a Wi-Fi signal is a medium. And we'll get to that in a minute, but we are talking about the computer's functions: input, processing, and output. Input is simply just taking a letter, typing a letter on the keyboard, and the computer doing something with it, or moving the mouse around will cause the mouse pointer to move around on the desktop. Processing, when the user clicks on something using the mouse, that will create what's called an event in the computer, and the computer will start processing whatever it's given at that point in time. You can essentially say that even every time you move the mouse, a processing event occurs. When you move a mouse from one position to the next across the screen, it's doing a calculation very, very fast to get it to the next point. That's how it runs so smoothly on a computer screen. When I first started working with computers, when I saw a mouse for the first time, my mind was blown, and I didn't even know how to use it. I didn't know how to move it, and someone had to show me, and I had to physically move my hand around to show me how to use the thing. So they're really, really interesting devices, and they handle real-time processing because they have to. They have to be able to redraw that little pointer on the screen thousands and thousands of times a second. And then you have output. Output is really what you see on when you move the mouse and the mouse cursor moves, the little arrow moves, that's output, right? If I were to write on the screen, which I did earlier, that is output. This, sorry, didn't mean to skip forward. This slide set is an output. The screen is an output. Some computer components are designed to perform only one of these three functions. Others are designed to perform two or all three. Yes, most computers can do all three. Most computers, like your phone, can do all three. It has to. It's the input, processing, and output all kind of built in together. Let's see here. Some computer components designed to perform. Oh yeah, we already got on that. That one. Input components. Input components includes user control devices, keyboards, mice, scanners, webcams. External interfaces such as serial cable, what they call firewire, which ended up being a Thunderbolt, USB ports. You're still using those, although different types of connectors. Some are faster than others with USB specifications. Input is also generated by storage devices such as hard disks and CDs. DVDs, you all still may have DVDs in your home, but I would say within the next 5 to 10 years, there won't be any physical media anymore. Now that Redbox is gone, maybe they'll still make the DVDs for people who want to collect or whatever. But CDs and DVDs are definitely going out, and streaming and services are all the rage now. Then you have inputs to a computer, can include timers that cause programs to run periodically. Yeah, you can set a computer to start at a specific time and shut down at a specific time. Some entities do this when they want to switch over their battery backups or what have you in a network network operating center. Basic functions again, processing components. Okay, the CPU is simply the central processing unit. It's in every device that is considered a computer. Just about every device out there now has especially if you want it to be on a network, it's going to have a CPU in it. Although one could probably make the argument that GPUs are going to be the new CPUs now that AI's causing its big stink, and those cards are getting very, very powerful, even more powerful than CPUs now. And so NVIDIA is already talking about making its own competitor to Intel and AMD and ARM and all of those other architectures. So be on the lookout. GPUs, we'll talk about those in a little bit, but CPU is really just the central processing unit. So it handles all the functions of a computer. You run commands through it, and it makes decisions based on those commands and so on. Or it runs signals through it. It makes decisions based on those signals and then does something with the computer. It just has billions of little pins inside of it, almost like virtual pins now. They're so small that they just, if a pin has power on it, then it's going to do something. If another pin has power on it, it's going to do something, so on and so forth. Then we have multi-core CPUs, which just about every computer in the world has multi-core CPU in it, which essentially is just that set of registers I was talking about. If you make smaller sets of clusters of registers in a CPU, you can have applications doing things or simulate what they call multitasking. No computer actually fully multitasks. If somebody tells you they're multitasking, they're really not. They're really fast switching. And that's all computers do. They just fast switch from one thing to the next. You just don't see it. It's magical. It's like it's doing things at the same time. But in reality, it's just moving really, 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 really fast, or changing operations really, really, really fast. Any questions so far? Let me know if I'm going too fast. Let's see, output components. The most obvious is monitor or printer. Your screen on your phone or device. Those are all output devices. You also have 3D printers now, which is a type of printer. And just about anything can be an output device if you want it to be. Output device can also be an external device, which is like a disk or something like that as well. You can output directly to external interfaces. A disk drive, many of you have, there are probably examples of those in the book. I'm not going to try to show any of this. I'm trying to move through this as quickly as I can so I can get to the next module. But if you want to see examples of any of those, let me know and I'll show you one. Otherwise, you should be able to find one in the book. Since this is just the computer components module, I'm gonna go over it kind of quick. The more storage computer has, the better the performance. The more components, most storage components are both input and output devices. That's right, that you can save as well as read from a device like a hard drive. There were in the old days you could set a device as read only. So if you had a piece of software that you were selling, you didn't, when somebody accidentally overwrite that software, you made that disk just readable only. You couldn't write to it. And then you have CDs and DVDs are generally unwritable, but there are some that can be both written to and read from. And of course, USB flash drives, there are also devices that you can read and write to, read from and write to. There are two main categories of storage: short-term storage and long-term storage. Short-term storage is the storage, your RAM memory is essentially short-term. It's the memory that's used to, when you open a document in Word or open a computer browser or open Blackboard or what have you, it takes up a certain amount of short-term memory so that it can draw the things on the screen. It handles all the data for that screen for you. So when you move a window around or when you move the mouse around, all of that is being stored in memory really fast and taken out of memory just as fast. Long-term storage is an external drive like your USB drives. Long-term storage would also be network storage, cloud storage like your OneDrives and those types of things, which we'll get to in a little while. I just talked about RAM, short-term storage. I'm not going to go through all that. I just explained the difference between long-term and short-term storage. Data is stored in bits. Bits is a bit is either, it's a series of values that are either 1 and 0, 1 or 0. So you can have 4 bits will have 4 distinct values in it. So you might have a 0000, that will mean something. A 0001, that will mean something else. 0011 would mean something else to the computer. So everything stored on a computer is stored as binary or bits, binary digits that will have a 1 or a 0 value. A pulse of 5 volts electricity. I think it's kind of overkill for this class, but yeah. A pulse of 5 volts electricity can represent 1 bit, and a pulse of 0 volts is a 0 bit. So, so the presence of electricity. So if you turn on a light switch, that's a 1. You turn off a light switch, that's a 0. Just think of it that way. A byte is a collection of 8 bits. So I mentioned earlier there were 4. You could have 8 in a collection. Most computers have 64 in a collection. It used to be only 4, and then it became 8, and then it became 16 and 32, and now 64. And they might have bigger ones now. They probably do. I haven't purchased anything bigger than a 64-bit computer in quite some time. They're usually server-based and they're custom machines. They're usually cloud or virtualized machines designed for a specific purpose. They'll have up to 256 bits or so of processing power. Table 1-2 on the following shows a way to express bytes and bits. So these are all they say these were bits. Let me see, next, bits and bytes. Okay, so it's the same. The breakdown is the same. You can either make them bits or bytes. A kilobyte is a K. So whenever you see 56K, that's 56,000 bits. But it usually tells you at the end of it if it's a bit or a byte. Megabyte, gigabyte, we're still using gigabyte things now. Terabytes, most of you might have a 1 or 2 terabyte drive, which is weird because, terabyte drives came out at least 8 years ago, or maybe even 10 years ago. And they're still, as most people don't use much more than a terabyte of data, I guess they've slowed down quite a bit. And then the next jump is a petabyte, which is 1,000 terabytes. And if you look at that, these all break down by 1,000, right? A megabyte is 1,000K, a gigabyte is 1,000 megabytes, a terabyte is 1,000 gigabytes, and so on. So everything breaks down by 1,000. And you have the exabyte and the zettabyte and then the yottabyte. I don't think anything's going to have anything that big in it. Maybe your quantums. If you're talking quantum, you're going to be speaking a completely different language anyway. There are 4 major PC components. You have the motherboard, storage device, RAM, firmware. Is it 1218 already? Yeah, I'm not going to go into what each one of these is. Just a major PC has a motherboard, storage, RAM, and firmware. We'll leave it at that. I really need to get into the next section. This is what a main board looks like. This is on the video, so you can pause the video later when it's uploaded. Let's see here. Personal computer hardware. Have all the different things on a main board. The main thing you want to notice on a motherboard is its network connector, which is not showing here. The SATA, chipset, RAM, PCI bus, PCI expansion slots. They're usually probably in the PCI or PCI Express slots, I guess, the network components. I guess in this case, they're not telling you where they are. Computer bus fundamentals. No, we're not going to get into that. SSDs are your typical output drives, and you have your RAM fundamentals. Just know that RAM is what they call non-volatile storage, which means that when you turn the computer off, all the memory goes away. So RAM memory, anything that your Word file or whatever, if you hadn't saved it yet and the computer goes off, all that goes away and you cry for a couple of days and you start the paper over again if you hadn't saved it. If you had saved the paper, then you would have saved it to you would have saved it to non-volatile memory. Let me step back. Forget everything I just said. Volatile memory is the memory that's destroyed when you turn the computer off. Non-volatile memory is what's saved on a hard disk. My apologies for having a little bit of a brain fart there. So non-volatile memory is saved to a disk. That's why they call it non-volatile. Volatile memory is memory that is only on as long as the computer's on or the device has power. My apologies for that. You do need to know that because somebody somewhere along the way is going to use that as a trick question for you, maybe in a screening interview or something. So understand what volatile memory is, or at least take note of it. Then you have firmware fundamentals. Firmware is just basically software it's hardware that can be programmable. That's firmware. So your phones are all considered firmware because they are really just memory that is updatable, hard drives that are updatable. And that's what firmware is. Firmwares are typically on smaller devices like your network devices and so forth. To take a computer from powered off state, see here, computer boot procedure. We're not going to do that. No, we don't need to see any of that. You know how a computer boots up. I'm not going to spend any more time on that. If you need to know more about that, let me know. I will. I can take you into that, but this stuff is just very, very basic. Okay, you have your network components. This is really what I wanted to get into. Your networks components on a computer involve a network card and some type of device that connects the computers together. Network components, let's see, let's go back here. Why did this jump around on me? Sorry. Okay, yeah, network clients, network can be clients and server. So you have your network here. One of these devices could be a server, and one of these devices could be a client when they're talking to one another. And that's really what they're saying here. You have network client software, you have network server software. Network server software would run on the server software, the network client software would run on the client software. Some computers run as both. You have your protocols, which are, we'll talk about in a bit. And you have a NIC driver, which is your network interface card, which they didn't show you in the hardware earlier. Network interface cards are what takes your physical media, like it looks like a little phone cable. You plug it in to the little jack and plug one into the little jack and the other into the back of your computer in a little jack that looks the same. And the NIC is the device inside the computer, the network interface card. And they usually call those physical NICs, network interface card. And so you have your Ethernet properties on a PC. I want to show you this because you will probably need to know these for the quizzes and stuff now that we're getting into the actual networking internals. Your network card is going to be shown at the top, and this is a Windows view. This is not a Mac. A Mac is completely different. So you have your network NIC card here, it's the name of it, and its driver. And then you have here all protocols. These guys here work with this guy here. Once a network card is installed, these things operate on top of this. And when I say on top of, we talk about things in terms of stacks. So there are different layers to communication. And it works in this way. An application tries to access the network resource. By sending a message, the client software formats the message in a way that's readable by the system on the other end. Protocol packages turn those messages into a format that's readable by the hardware, and the NIC driver does the actual moving of the data into the hardware components. Layers of the network communication process. Each step required for a client to access a network resource is referred to as a layer. That's what I was talking about earlier. You have a layer of operation. Each layer has a task, and all layers work together on top of one another. As you can imagine, this next table here, you have a stack of operations here. You have user application, network software, network protocol, network interface, and network medium. And so on the sending machine, everything kind of works down, starts from the application, say Word or email. Let's say you're using opening email, you want to send an email, and then you hit send on the email, and then the network software takes over and it converts that message into something readable by the network protocol. The network protocol is what's assigned to your network adapter. And then that in turn takes all that information and turns it into something the network interface can use. And the network interface really prepares all the data and everything so that it can be sent over the network medium. And the network medium, we'll talk about in a minute, is just how the data is transmitted in some either electronically or by light or by radio or something along those lines, by wire. And then when it comes out on the other end, it's going to go back through the network interface on that machine. It's going to go back through the network protocol. Just think of it unwinding. It's packaging here, and then it's unpacking here. So it's like packing up a box over here on the sending machine, and then it's going to unpack that box over here. Network interface is going to do its part, prepare it for the network protocol. The network protocol is going to do its part to prepare it for the networking software, which would be, the something that works between the application and like the email program. And then it'll take you actually back to your email program, the user application like Microsoft Outlook. I know I went through that kind of fast, but we're going to see this layer over and over and over in this class. Layers of the network process. It's basically what I told you earlier. You can read that later. I'm not going to read that out to you. It's essentially how I explained to you in the diagram on the previous slide. TCP/IP is the most common protocol language out there. Yes, TCP/IP or TP/IP is just called TCP/IP, and it is transfer control protocol or internet protocol. They kind of put them both together. They used to be two separate things. Now they're all the same thing. Uses two addresses to identify devices, a logical address that is called an IP address, internet protocol address, and it has a physical address, a MAC address, machine hardware address. And we'll talk about those in the next segment, I think. It may be in the next slide, but I think it's in the next slide set. Just as a mail person needs an address to deliver mail, TCP/IP needs an address to deliver, and that's really all the addresses are. A MAC address doesn't change, but an IP address can. MAC address is specific to the card it lives on. And so you think of the logical address as a zip code, think of the physical address as a straight address. Yeah, you can think of that way as well. But I wouldn't even think of it this way. Actually, that's a horrible analogy. Forget that last line. That is not, zip code is not a logical address. A logical address for a physical address would be my house. Or the third house down. It would not be an entire zip code. That is not correct analogy at all. Let's see here next. Okay, how two computers communicate on a LAN. A user at computer A types ping 10.1.1.2 at a command prompt. Okay, so just think of the user typing in something into a command prompt, and they're typing this address, 10.1.1.2. The network software creates a ping message. Then the ping message is sent out using the network protocol packages, message by adding the IP address and sending the destination. What is this thing saying? The network protocol packages the message by adding IP address and sending destination computers, and acquires the destination computer's MAC address. So it does a bunch of things in this part of this setting up this ping message, and then the network interface adds the MAC address of the sending and destination computers, and then the computer B receives the message and then undoes everything, and then gets sends back a reply, and then a reply goes back up this 5, 4, 3, 2, 1 back to the computer, saying that it made it. Okay, so let's see if they have a diagram, because that's kind of a weird way of showing it. Okay, yeah. So this one here, what happens here is this computer. This is the way it works. The computer will. It's a crazy thing. Hello. All right. 10.1.1.2 is essentially the name of this computer, the protocol address, with the MAC address BB1, that's its physical address, MAC hardware. And then you have the MAC address here for this computer, and this IP address is 10.1.1.1. So you can see this 10.1.1.2 and 10.1.1.1, so that we know that these are on the same network. They have different hardware addresses, MAC addresses. You have BB here and AA here. You can see they're two completely different machines. They're connected to one another. And one machine will send a ping. I don't know why this thing keeps hitting. Thanks. This machine will send a ping to this computer. The ping will be sent through this little device here we call a hub. We'll talk about later. And then or through the network and through the internet or wherever, and it's going to send it to this computer. So it's going to go through this device and send it back out. Actually, these two are connected to the same what they call the same hub. So it's not going to send it through the internet. It's just going to send it through this device, these two devices connected directly together. So this computer will receive the ping, say hello, and then send the message back to this one saying, I got your message, and so forth. You have any questions so far? Is this going too fast? All good? Okay. Network terms explained. Let me take a drink here real quick. If you need to leave, it is 12:30. If you need to leave, you can. Otherwise, I'm just going to finish this, or until somebody tries to take over the room. Okay. So the network terms explained. Every profession has its own language and acronyms, and I rattled off a bunch of those earlier. TCP/IP, all of those wonderful things, hubs, and those are all terms that are used in networking commonly. It's essential to know the language of networks and be able to study them and be able to communicate them. Maybe even to your charter repairman when he comes out to change out your router, because they use the same concept. They use the same TCP/IP networking that you're learning here. Okay, so we have this idea of LANs, inner networks, and every book has its own name for this. But usually you have LANs, WANs, and MANs, but now they have quote unquote inner networks. And I don't know why they call them inner networks. It's kind of a silly name. This is definitely not an industry term. But I'll get past it. LAN stands for local area network. Inner network stands for whatever that is. WANs are wide area networks, which is any LAN, multiple LANs connected together from different locations. And you have MANs, metropolitan area networks. Local area networks, as I said earlier, are just a small set of computers like the one we saw here. This is a LAN setup right here. And I think that we'll see visualizations of those in a second. Then you have an inner network, as a network collection of LANs tied together by devices such as routers. I don't understand that term. Yeah, all of them are connected by routers. It's either a WAN or it's a or a MAN. Two or more groups of users. Let's see the reason for the creation. Two or more groups of users and their computers need to be logically separated, but still need to communicate. Number of computers in a single LAN has grown and is no longer efficient. And the distance between two groups of computers exceeds the capabilities of most LAN devices. Oh, I got you now. I got you now. Now I understand what they're trying to do. They're trying to manage networks. It's not inner networks, it's managed networks. They use managed switches. Okay, so this name is suspect. But for the case, in the case of the quiz, if they ask you what an inner network is, it's really just two networks connected within the same building, still separated by routers. They're just not wide area. They're just kind of in between. So let's show you a little bit of what's going on in my head, because you guys are looking at the computer and kind of scratching your head like, what in the heck? Me just spouting off and griping about inner networks. We have here a switch in the middle, and then around that switch is a series of computers. This is a LAN that is interconnected by a switch, and that's essentially one network. It's just a single LAN. And a lot of times you'll just see just switches now, but you're going to see another little device later. In the next module, we'll talk about hubs. LAN. Let's see here. Let's not read the title again. You have here a wireless LAN. So you have here in the middle a Wi-Fi access point. And then what happens here is you have a wire, that's what these little signals are here, this little radio signal. And this wireless tablet is sending out a signal, and this wireless PC is sending out a signal, and this wireless laptop is sending out a signal. They're all radio signals. There's no wires. You can see there's no physical wire anywhere. It's just all that's what these lines are. They're just sending out a signal, and they're also listening for a signal. This Wi-Fi access point to this wireless access point right here is receiving the signals from all these devices. Whether it wants to or not, it's receiving the signals from all these devices. And it's going to make sense of all of that traffic and say, do you belong to me? Do I know you? It's like having a doorman, right? And so the wireless access point is going to authorize these devices and allow communication with one another. That's what the access point, that's the point of an access point, is to control access to other devices, other radio networks. Think of this like I don't know, you probably don't remember the old style telephones were before smartphones. They were just voice gadgets. And that's really the way those things worked. The telephone system, you had to actually authenticate with a phone number in order to receive at a station. The station had to know your phone number, otherwise it's just going to ignore it. But it's the same concept as although completely different architecture, but it's the same concept, using radio waves to send data. You have LANs. Again, what are these? These are a LAN with a symbolic hub and a symbolic switch. Okay. So a LAN with a hub and a LAN with a switch. A LAN using a hub is going to be different than a LAN using a switch. And we'll get into that in a minute on the difference. But these are two different ways of connecting computers. This is the old way, the hub way, and this is more modern day switches. Then you have an inner network with two LANs connected by a router. This is this inner network thing where you can have in the same building, you have a huge building, you have thousands of users, and you need to separate all those users. You can only handle a certain amount of data on wires before you start getting lost and a lot of problems. So it's easier to manage with routers and separate out networks within even the same building. I think in your dorms, each one of your dorms or wherever you're living, they're going to have a different router for every building. And possibly every floor, who knows? Because there are just so many devices out there now. Every person comes with it at least 5 different IP addresses, depending on the phone or some other device you have on you. There are IP addresses owned or needed by a single individual. Well, someone who's connected. If you're living in the boondocks, you're not going to encounter that as much. You're not going to need networks. If you're living where there's no service and no electricity, you're off the grid, as they say. You don't need any of this stuff. You wouldn't need internet protocol or IP addresses. But even here in Spartanburg, we need to separate buildings out, separate buildings into multiple routes or into multiple LANs, and having a router in between them. And I guess that's why they're calling this internet networks now. That's because it's become so popular, but there's another name for it, it's managed network. And we have wide area networks, which is essentially network that leaves your environment, your networking environment completely to a completely separate entity altogether. Some entities like the University of South Carolina, they're all connected through either a MAN or a or one of these little inter-network things. And in the old days, they had WAN meant both. The inter-network thing and it meant just a wide area network meant a LAN outside of another network. But in today's needs, a WAN is just outside your building where you connect more than one building together. You'll have its own network. And then metropolitan area networks are for large regional areas. Say you want the entire city of Atlanta on a single domain of networks, and that would be a metropolitan area network. Your MANs are going to be like your when they offer public Wi-Fi and things of that nature, they're probably going to need MANs for those. I haven't really encountered a MAN ever. I guess I've just haven't been in a big enough city. Maybe in New York they need MANs, but out here in this area of the world, we just don't need them. We don't use them. We use WANs and managed networks. A WAN with a connection to the internet. Generally, yes, a wide area network connection can happen without having the internet on it. Those are called leased lines or fiber optic lines. You can actually buy something from the actually lease a physical cable between two buildings. Essentially, they make one long cable, not physically, but logical long cable, and those two buildings are connected together by that one cable, and that's essentially a WAN connection. So you need a router at one building, and you need another router at another building, and those two routers talk to one another and make that wide area connection. And then you can have the internet on top of that. WAN or wide area network connections are for companies that do not want to have employees. They don't want the employees to have internet connections, or they don't want internet in their businesses at all. You look at some countries out in the world. I'm not going to name them, but they don't want people browsing the web. They don't want people on the web at all. And so the internet is not even possible. So they'll have more wide area connections where their businesses connect to one another, but they can't get to anything out on the World Wide Web, such as uscupstate.edu, the ever popular domain. All right. It's WAN, internet, intranet, extranet. Internet is essentially just a group of connected computers that are on separate networks. They're all interconnected networks. That's what an internet is. That simple. Then you have on top of the internet, you have the World Wide Web, but what you see as like www.apple.com or Facebook.com or one of the apps on your phone, maybe, they all use World Wide Web. They use web addresses, and that's the World Wide Web Consortium. So the WAN, not WAN, but the World Wide Web sits on top of the internet. So you have the internet, and then you have an intranet, which is essentially a special network within a building of resources. The internet was essentially designed to share information and share resources among computers, and it was generally open. But an intranet is a closed network. It's private. And then you have an extranet, which allows limited access to external resources. Get another drink here. Let's talk about packets and frames. Packets and frames are generally the logical way data moves through a network, the actual data packages and the control of that, where the routing of that data. Think of a packet as a mailman. He has his mailbag with a bunch of messages in it, and a packet is going to be the mailman, essentially. And the mailman's going to carry that data somewhere, or it's going to carry it back to the main post office, and then it'll be rerouted. But packets essentially are essentially hold data and have information about them, that so they know how they're routed, where they're sent to with an address. Just think of it just as really as a package you want to send in the mail. It has to have an address on it for it to go somewhere. Otherwise, if it doesn't have an address, it's just going to sit there. So we have packets, or chunks of data sent across network. Yeah, what I said earlier is just packets, just chunks of data. And then the frame is a packet with the source and destination information together. The frame has the routing information, the packet has the actual data. A client is a computer, or essentially a system that just, it needs another system to exist. So in the old days, you had just one computer, and that person used that one computer, and everybody had to kind of take turns using that one computer. And so when they decided to network things, well, okay, well, we can have these two people we can give a computer to each one of these individuals, and they can work, and they don't have to swap back and forth. They each have their own dedicated computer, but then they needed to talk to one another. And so they were still clients at that point, as they were still just, they were just their own individual. They were standalone computers is what they were. They were standalone. They weren't even servers yet. They weren't even clients yet. But then one day they decided, hey, if we made a third computer, we could put information on a third computer that we both can share, right? So they added a third computer, and that third computer became the server, where they held all the information they needed to share. And then the two computers that accessed that server would be the clients. And so that's where client server or client host, client server relationship started. And it's been that way ever since. So they have here client. Client is usually used in these three contexts: a client operating system. That is the operating system installed on the computer. So a Windows computer will have a different client operating system than a Mac. Then you have the client computer itself. It's the primary role is to run user applications. So you have the computer itself, and you have the operating system. And then you have the client software, which is software that requests network resources from the server software onto another computer. So you have your client software, your client computer, and the client software is essentially specialized software that connects to a server computer, and it's specially designed for it. Think of Microsoft Outlook as sorry, I thought I saw something pop up on the screen. I guess everybody's okay. Everybody's still online. That's good. So client software would be like Microsoft Outlook, the actual physical application that's on your computer that you use, Outlook. Another client operating system would be Snapchat, like on your phone. That's the client software. On your phone, your client operating system is iOS, and the client computer is the actual iPhone itself. Server has a special case. It just kind of sits alone, and or with its friends' other servers, and it holds a sizable amount of data in it that can be shared out to clients as needed. The whole reason you need a server is when you have multiple people needing access to the same information or needing to be able to change the same information. So servers were created so that clients could connect to them. So the term server is also used in these three contexts. You have server operating system, OS installed on a computer designed to share network resources. And so server operating system, it used to be Windows NT, now it's Windows Server. I don't know where they're at now, probably 2024 now. I don't know what the latest and greatest is these days on the server side. The last time I used it was Windows Server 10. And I think a lot of companies, they don't change their server operating systems that often because they are expensive. And then, so it still could be Server 10, Windows Server. And maybe they just call it Windows Server now and they don't even have a label anymore. I know that they were talking about doing that at the time of switching to a newer version. Then you have the server computer. The server computer is the actual physical device it sits on. And it's designed to have all of the features, networking features designed to handle large loads of data transmission. And then you have server software, which is special software just that a server can use, like a database software, something along those lines. Server software runs on a server operating system. And this is all introductory information. We're going to get into detail on all of these things. So I'm not going to go into too much detail, and that's why they didn't in this PowerPoint slide set. Network model. I talked earlier about how they had two people and they're fighting over using the computer, and they got two computers, but they still needed to share data with one another, but they didn't have a server yet. When you connect two computers together without a server, they're both clients, essentially, both client and server, they're called peer-to-peer. They talk to one another directly, and there's nothing in between them. There's no other server. There's nothing. It's just the two devices are connected directly together. And then you have a server-based network, which gets back to that client-server architecture I talked about earlier. Peer-to-peer workgroup model. Let's not go into that right now. We'll get into that when we get into the different actual server types. A second. Peer-to-peer workgroup model, server domain-based model. Yeah, these are just how you control users on the peer-to-peer workgroup model and the server domain-based model. These are just how you manage users who access the server. And that's really all they're covering here. I'm not going to go into each one of those because we're going to hit this all in great detail later. Just know that you need domain controllers for a domain-based system. In a work group model, you don't need a domain. You can work with a domain, but you don't have to. Server domain based, you have to have a domain controller that controls the authenticated users. Yeah, let's not get into that. There's a lot of slides in this thing. It's a lot more slides than I thought there were. Oh, there's only a couple more. It's like 50-some slides. So we're almost there anyway. Resource access, security, performance cost. These are all attributes related to what? Resource access. Distributed among, okay. So what's having here is the network attribute. If you need a certain type of resource, this is how these things work, peer-to-peer versus a server-based. Let's not get into those because there's really, we're going to look at that in detail later. when we get into actual server operating systems. All right. So that is all about the basics of computers, the very, very, very basics of networking. And I thought I was going to be able to do both modules today, but I didn't think this slide set was this large. I only saw 20 slides earlier when I went through it, and so I must have somehow skipped them. So I was wondering why this thing was taking a lot longer. So what we're going to do is stop here today, and then we'll go over. Well, I'll try to go over two of them next week. Again, maybe they'll be a little shorter, or I'll pick and choose better. But I think this is a good place to stop, primarily because my voice is going out, because I'm not 100% yet from my illness last week. I do appreciate you being patient. And does anybody have any questions? One last time. If there are no questions, I will say adios and thank you all for joining, and we will see you next week. Thank you. Thank you so much. Appreciate it. Bye-bye, y'all.